Hello, welcome back. So today we're going to continue a little extension for limits. So this is some extra example for limits. So now we're going to go for the section that talks about the substitution of these limits using substitution, direct substitute value into the function. So for now we're going to focus on the parts where the main frame of here, the function is actually a constant value. So if it's a constant value with x approach 0 over here, it's actually a straight line. So when it's a straight line, whatever changes happens at the x axis doesn't affect the value of the fx. So it's going to remain the same. So as we can see the answer here, according to the property of limits, whatever value for constant, we're going to remain constant and it's going to be same. Okay, now we're going to go for the next question. In this one, now if you look at this question, it has a limit of x approach 2 for this quadratic function. So what we do is we just direct substitute the value of x into it, and there we have it, 2 with 2 minus 3 over here, and simplify to be negative 2 over here. Now this system got lots of questions. It's generally unlimited source of questions, so there's no limit for this. You can go to thousands of questions. So we're gonna pick a few questions and discuss with you all. That's it. So now this is the third question where you have this as a fraction of function. So as we can see over here, now it's a fraction of function, direct substitute without doing any factor or whatever. Now this is because the denominator is not 0. So if you substitute the value in here, the denominator remain with a number, doesn't have any 0 value, but the upper is different. Nominator gets 0, is okay. So we get a 0 over here after we substitute the value of x into it. Now we go for the next. Okay, now this one same as well. After you substitute negative 1 into the function over here, it do not turn into 0. So which means that you can just direct substitute. If it's not 0, then you can direct substitute any value into it. So what we have over here is that it is actually negative 1 plus this plus 1, negative 1 minus 1. So this is actually equals to 0. So coincidentally you get a 0 over here. Okay, now the next question will be a bit tougher one. So it's not so hard, but still level up a little bit. So we have the fraction of a polynomial. So this is x squared minus 6x plus 8 divided by x minus 4 with x approach to 5. So from here we can see that if we substitute value of 5 into here, it never going to turn into 0. So we could actually use this by direct substitute the value in, and this is what we have. After we substitute x equals to 5 into here, this is what we have, which is equals to 3. So I'm going to skip all this one since it's quite simple direct substitute. So now we're going to move to the section over here, which is involving factoring. Now factoring only happen if it's only required if you substitute the x value in and it seems like you have what we call this 0 for the denominator. When you substitute this thing in, you get a 0. You cannot solve. That's a dead end. So we have to find a way to actually change this function into something that, you have to process it into something that edible. It is food. But this for the function, we change it to something that we can use to substitute the value and it gives you some output. So we have to change this part. Now direct substitute, we're going to get 0. So over here what we did is we're going to do some little factoring. So when you want to do factoring, actually we can refer to the parts that is shorter over here, the short function over here. This one you can take it as a guideline to factor whatever at the upper top over here, the denominator. So we directly just use this x minus 4 over here, and we find the factor for this polynomial, this quadratic function over here. So the easiest part is taking this 8, okay, divide by negative 4 over here. Okay, this n of this number over here, 8, divide by negative 4 over here, you get negative 2. So negative 2 will be placed over this side, and just double check again in case there's a mistake or something. Just have to be cautious. So we have x minus 2, and this one, check, yes, is the correct answer. So now we can use these forms of the function, the quadratic function that already factored, and we're gonna do a little elimination. So we're gonna cancel out this one, negative 4 and negative 4. There only left x minus 2. Now the limit for x approach 4 for this function is already changing its shape into x minus 2, which is usable. We're gonna substitute the value in, and what we get over here is x equals to 2. So this is what we get, x equals to this limit is equals to 2. Okay, we're gonna go to another question. Okay, now this case both power are equal. Okay, this is equal level power, both of them are quadratic, so there's no any hint that we can use to do the factor. Okay, and some more, substituting negative 5 to the denominator, we're gonna get you 0. So what we see over here is that we have one way only to solve this, okay, by factoring the upper level. So of course we're gonna try to find the smallest number of factor that suit this to get where they both multiply and get 25. So what came out in your mind is 5 squared. So over here we change it to x minus 5, x plus 5 over here. Then the below, of course, there will be one part that are equals to the above. One of it surely going to be equal, so we're going to pick one of them, which is since it's negative 5 over here, so we just pick one of them, randomly pick as x is equals to this factor is equals to x minus 5 or x plus 5. So if it's x plus 5, assume so lah, we assume that this is x plus 5. So we take this negative 5 over here, divide by 5. Divide by 5, you get negative 1. So we substitute the value negative 1 in here and double check again. Is it after you multiply you get the same function out of this? Yes. So if yes, then you can proceed. So that means above we already have the value, the factor, which is x plus 5, x minus 5, and below we get this one over here and place it below. Now we can do the cancelling. So the cancelling only happens for x plus 5 over here, and this one will remain. So this will be x minus 5 and x plus 1 remain over here. Now settle out for the limits. You can substitute the value of negative 5 into it, and you have the result as 5 over 2, 5 over 3. Now this one will get you 0, don't worry. Okay, I'll go for the next question. Okay, now this question, the power above is bigger than below, and because this one is a good sign that you can use the below as part of its factor, so you can use it part of the factor. So what we can see over here is that you can check. Now above is x power 3 minus x. So in order to change the shape for the numerator become precisely same as the denominator, we just grab this x out. So bring it out, factor the thing out, and it become x multiplied with x squared minus 1. So the above will change into this form, and they can cancel each other out. So when they cancel out, the result is only x. And when it's x, what we need, now we can directly substitute 1 into it, and there you go, you get the answer is equals to 1. Okay, compared to the previous original form, when you put 1 into it, the denominator turns into 0 and it's unsolvable. Okay, so this is one of the way how we transform the function into something that is solvable. Okay, now I tried to find some example that with similar power. Okay, this one similar power, but it's too simple. It doesn't need to do much of the factors. Let's see. Most of them have similar power. Never mind, I'm gonna move to the last example over here. So now the last example is this one, or this section. Okay, we have x negative 1. Now you can see precisely when you substitute this value in, you're gonna get denominator equals 0, which is unable to solve for this limit. So what we do, we have to run a little transformation for this function, and this is what we're doing. So we're going to factor the above and using the value below here as the factors, because this one got smaller power compared to the above, so we're going to use it as part of the factors. So we're going to put like this. So this is a function above. Okay, we're going to copy paste this x minus 1 over here. Okay, this x plus 1 over here, and put it in this side. Now the other side, what we need to do is we're gonna take this 2x squared, okay, 2x squared divide by x over here, so you get 2x over here, and then the end over here, negative 3, you're gonna divide with 1. So you take this, divide by this, you get 2. This divide with the function over here, this the middle doesn't touch, we don't play anything with the middle one. You only take the head and the tail, same as here, head and tail. So the tail will match with the tail, head with the head. So tail will be this one, negative 3 divided by 1, which is negative 3. There you go, you have another function at the back. So you have another function at the back. We can proceed to this section now. This one will be placed at the top, and the one below remain the same. So we can cancel this one out, and the result will be 2x minus 3 over here. So now whatever you substitute, whenever you substitute the value of negative 1, it won't change into 0. So you can proceed substituting it and get the value which is equals to negative 5. Okay, now moving on to the other case. Now this is a case where you have to find the conjugate. Now the things happens here, the situation happens here is the same, which is the indeterminate situation. What I say by indeterminate is that whenever you substitute the value of x approach 4 or something into whatever value, x approach whatever value over here that has been that you try to substitute over here to the denominator, and you're gonna notice that the denominator will gonna become changed to 0, and it's not solvable. Okay, so when the situation happens like that, you have a few choices to do. One is that you can use factoring. 2 is you might have to use conjugate. It depends on the function. Is the function have cases like square root of function, and then you can use conjugate. But if the function doesn't have that, it's just a polynomial, then you can use factor. Or probably if there's infinity case, then you have to do the division. Okay, so we look at the first example over here. Now, this first example, as we can see, if you direct substitute the value, you're going to get 0 over here. So what we did is that we're going to multiply this function over here with its conjugate. Now, as we know, whatever behind here, actually there's 1. This function multiplied with 1. So if you want to multiply anything, it could be 2 divided by 2, 3 divided by 3, 100 divided by 100. Everything gonna give you the same value, which is 1. Okay, so to make good use of this, it's better we just multiply with its own conjugate, and that probably might gonna transform the function into something that is more processable. So now this is the conjugate that we're going to use, where you have this square root of x minus 2, right? So this one change it to square root plus 2 instead. Okay, now from here we're going to put this thing in, right, up and down like this in a pair, because these two will cancel each other out and turn into 1. So it doesn't affect the function at all. You see, it's still the same. If you compare this one and this one, same. After this cancel is the same. But what we do is we are not cancelling it. Instead, we multiply it into the function over here. So when we do the multiplication, this one we're going to change into x minus 4. Okay, this is going to change into x minus 4. And the value below, okay, x minus 4 will be placed at the above. And you can see directly that these two can cancel each other out. So when they cancel each other for this x minus 4, this is a function, the new function that you have, a new phase of this function. And this one, usually the function that after process won't get you 0 for the denominator. So when you substitute the value 4 into here, you are going to get something out of it instead of getting 0. So the value that we have after substitution is equals to 1 over 4. Okay, now I'm going to go to another question. Okay, this one is the same. This is a good example. Okay, now this is the reverse. Instead of the function of square root x at the front, now it's at the back. Okay, so I'm going to show you what happened if like this. Now the same thing apply. The back over here is always 1. So instead of putting something, it's good that we put something usable at the back. So we're placing the conjugate over here, where the conjugate is actually 2 plus square root of x, the anti of this form. But we put it up and down over here, so it's going to multiply like this. Okay, up and down. Now instead of cancelling these two, we just multiply directly into it, and what we have is 4 minus x over here after multiplication. This is the result. Okay, so this one will be placed at the top and the bottom will remain the same. Now I don't know what happened to the algorithm over here. Suddenly it kind of shift this negative x to the front, but it's actually unnecessary since you can see this one and this one are the same, so they can cancel each other. This one can cancel, so they cancel it, gone. You only have the result as 1 divided by square root of x plus 2. So this is a newly processed function which not gonna get you any 0 for the denominator, so don't worry about that. Okay, now you can substitute the value of x equals to 4 into it, and you're gonna have the result as 1 over 4. Okay, and this is the second question. I'm gonna find another one over here. Now this is for the infinity. This is for the infinite cases. Okay. Now there is also this type of cases where no, this is not such a good one. Infinity. Okay. Now there's such a cases like this also, where you have to seems like something happened to the system, so never mind. Move to the next question. Okay, now this is the last example I'm going to show for this section. Okay. Now you see there's a situation when infinity is putting in here. So when you put infinity, you cannot declare that this thing turned into 0. No, it's not 0, but it is there's a value over here, but we are not sure what kind of value. Is it big or small? Not sure. The upper part also is getting the same thing. It's an unsure value. Okay, so we cannot solve with unsure value. We need to have some value over here. So that means this thing needs to be processed. So when the thing needs to be processed, what we do is we're going to focus more on the denominator, because denominator is the most important part for this function. If it turns into 0, it is not solvable. But if it's not 0, then it's okay. We can proceed with something. So this is a part that we have to take care of. We have to look for the biggest power over here, which is square. x squared. So you can see over here, when we do the division for x squared, we're going to divide everything over here with x squared. Okay, we divide everything with x squared. Everything. Now, this is what actually happened. Over here, we divide x squared for everything. Okay, the up and down, everything the same. So this can cancel each other out. And when it happens over here, what we have is this one turn into 1. This one is equal to 1. This one, the power square root of x, deduct with, that means 1 over 2, divide, subtract with 2, you get negative 3 over 2. So it turn into 1 divided by x power 3 over 2 here, and this one become what, 4 over x. Now if it turn into this, is a good thing. Some more this x squared also can be cancelled out, and this is the final form of the function. So we put it back into here. As I say, anything divided by infinity will turn into almost near 0, or you can declare as 0. So when you put the thing in over here, okay, this is what actually happened. When you put this okay, infinity into here and into here, these two will turn into 0. This also turn into 0. Okay, this one turn into 0. So that means this only left 1, this one only left negative 1. So 1 divided by negative 1, you get negative 1. So that's the result. Okay, now we're going to go to the last section, which is the what we call the rational function. Okay, now rational function mainly focus on the infinity, because the infinity parts is quite hard to solve, especially for the case like this. For example, I'm going to show you some example. Now we're not going to take the highest power instead, because we only focus on the denominator. The denominator must never be 0. So this is the most important part of the choice that you have to make. Okay, so now let's see this thing. Okay, now in order to solve this, since it's infinity divided by infinity, so we can declare that this thing is equal to 1, because the number might be big or small. So unsure, something unsure is undeclarable. Okay, so what happened is that since the power for the denominator, the biggest one for the denominator is 3, so we're going to divide everything with x power 3. So we pull x power 3 out, and we divide everything with x power 3 over here. So when we do so, this one will turn into 5, this one will turn into x power 3, this will turn into 4 divided by x, and this will be 1 over x power 3. Okay, so nothing happened because this is 1 divided by x power 3, so it remains the same, and the x power 3 can be cancelled out. So this is the final form of the function. Now what happened is that the final form of the function over here, when you substitute infinity to this fraction, usually the fraction will turn into extremely small value that almost near 0, or you can declare the thing as 0. So the last function that left over here is actually this is 0, this is infinity power 3, of course it's infinity, and the same goes for this one. This one is becoming 0, only left negative 5, so infinity divided by negative 5 is negative infinity. So it's logic sense. Okay, now we're gonna move to another question over here. This one, I give you some few variety because the system can generate unlimited source of question. So now I'm going to show you another example. I think that's it lah. This is an example. It is enough for you to use. You can see the variation. So the same case, if you substitute infinity over here, then both will become infinity divided infinity, which is an unsure value. Let me give you some example why I say so. I keep saying so. Now, assuming that the top's over here, infinity, but maybe this infinity is 12 digits number, while the one below over here might be 11 digits number. So is it you're gonna say that this is equals to 1? Not possible, right? It's just like 10 divided by 1. Is it equals to 1? Is equals to 10, right? Now the same thing goes if you say it's 1. It's not possible. Why? let's say again I change the thing. Now this is the above is 10 digit, okay, while the below is 12 digit. Then how you gonna say is it equals to 1? Now the situation now turn around, it's just like you taking 1 divided by 10. So it's no longer equals to 1, but instead it becomes 0.1. Now something like that might happen in the process. So that's why we cannot simply declare that infinity divided by infinity is equals to 1. No. Okay. Now for this case, we're gonna always look for the denominator. So the biggest power over here is equals to x power 4. So what we do is we're gonna divide everything, the upper and lower level, with x power 4. So we're gonna divide like this. We're gonna have this as a division of x power 4, power 4, power 4 over here, and the result that you get is from here turn into x. This one turn into 1 over x, and this is 1 over x power 3. This one, since it's divided with x power 4, you get 1. So now we have hopes because there's a number over here, and this 1 over x squared, 1 over x power 4. These two will cancel each other, gone. And this is the final form of the function. So we're gonna proceed it with here by substituting infinity into it. So when you substitute infinity into it, this will become 0, this will become 0, this will become infinity, and this also 0, 0, 1. So in the end you only have infinity and also 1 over here, which is the division of the upper form of function divided by this. So the final answer is equals to infinity lah. Okay, so now we're gonna move to the next question. Okay, so okay, now this is the last demonstration I'm going to show you in here for the example. So luckily these two have the same power, which makes it easy. So we're going to divide the largest power over here for the denominator. Denominator is the below one, not the upper one. The upper one is denominator. So we divide x squared over here. Okay, this is what we do. Divide x squared for both parts. So what we have is this one turn into 6, this one turn into 1, and this will remain as 12 over x squared and 3 over x. Okay, the squared now go down to x now because you will divide by x squared. The above is 3x will turn into here. Okay, now this x squared can cancel, and this is the final form of the function. So now we add it back to the limits over here, substitute the negative infinity into it. So any parts that have fraction of x over here usually gonna get 0. So we're gonna put this as 0, 0. So the final answer over here, the upper level will get negative 6, since this will become 0 over here. So it remains negative 6. This one becomes 0, it remains with only 1. So it becomes negative 6 divided by 1, which is equals to negative 6. So there you go. I hope you all get this variety of some example, and hope it helps in your study. So that's all.